So here we are, trying to figure out this particular problem. So suppose you toss two fair six-sided dice, and the random variable is the sum of the pips. Pips is the fancy name for dots. You know what? Let me remind everybody what the sample space for this looks like. Hold on, let me go get it. Poof, there it is. It's in the chapter 5 notes that we did. So here it is. 1, 1, 1, 2, 1, 3, and so on. So a sum of 2 would be right here, snake eyes. That's the only way you can get a sum of 2. A sum of 3 would be 2 and 1 or 1 and 2. So there's 2 ways to do that, and so on. And there's 36 total possible outcomes. We covered that in 5.1. So let's go back to here. There's only one way out of 36 possibilities to get that. 2 out of 36 to get this. Oopsie. 3 out of 36 to get this, and so on. Let me fill in the rest of this. Hold on. Poof. There they are, like magic. All right, so the biggest chance is rolling a 7, which is 6 out of 36. And snake eyes and boxcars, 12 and 2, each have a 1 out of 36 chance. Now, what kind of probability is this? This is an example of classical probability because dice were not rolled to compute the values. It was simply assumed that each side of each die was equally likely. In other words, you're figuring it out hypothetically. When you do that, that's classical probability. When you actually go to the trouble to roll them, that's empirical. So if I actually took 2 dice and rolled them and rolled them and rolled them, that would have been an empirical probability. Remember, that's another concept covered in Chapter 5. That happens a lot in Chapter 6, actually. We ended up running into a lot of things we've already done before. Okay, so which of the following are probability distributions? Now remember, you have to follow these 2 rules. You have to have the sum equal to 1, and you've got to have between 0 and 1. And just for the record, by the way, this adds up to 1. There's 36 different combinations there. All right, so let's see. Are the following probability distributions y or not, y not? So first thing you want to do is you want to check that these add up to 1. So 6, 7, 8, 9, 10. This adds up to 1, so this one's a yes. Each probability is between 0 and 1, and it adds up to 1. It doesn't matter that this is negative. You can have negative x, that's fine. You just can't have negative probabilities. What about over here? Well, it's kind of boring, but yeah, I mean, it's basically impossible, 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 impossible. Yay, that's a possibility. Okay, so boring, but true. Stop that. Now, what about down here? Ugh, that's a problem right there. See that? You can't have that. You can't have a negative probability. So this is a big fat no, because negative probabilities are not allowed. And this one's a big fat no. I can see it from here because the probabilities add up to more than, or will add up to anything different than 1. How about this way? Do not add up to 1. That's a problem. They need to add to 1. Otherwise, it's not a probability distribution. Cool. Done with that section. Next. All right, we have our number of home runs, our number of games, and our probabilities. We already figured this out from before, and I actually have it sitting in Excel right here. They want a probability histogram. So let's do that. Probability histogram is when you're going to make a histogram based off of these probabilities right here. So you just highlight the probabilities. You can highlight the top row or not. It doesn't really make any difference. And you go to the insert and you choose column. I'm going to go through this quickly because I, of course, have Excel videos that show you how to do this in greater depth. You just have to remember to change your horizontal axis labels. There we go. And of course, you want your bars to touch. So I'm going to format. And again, I'm not going through every single step that I'm doing here because I'm assuming you can go watch those videos. And there we go. We've got a probability histogram. Let me type in the titles. There we go. I went into the layout tab and added axis titles and a chart and such. So there we go. That's the probability histogram. And it's skewed right, as you can see. And that's going to answer the question of how is it skewed? Skewed right. All right, I'll see you here next time.